Hello, this is Dr. Hall. We are going to analyze the ankle and subtalar bony structure and articulations. And basically, the ankle joint or talocrural joint is a hinge joint formed by the articulation between three bones. And these bones are the tibia, the fibula, and the talus. And the primary function of foot complex are to provide stable base on which the body can stand, provide a mechanism to propel the body through space, and to conform to variation in the supporting surface. And the, the articulation or the structure of the ankle and foot is of two main articulation, tibia and the fibula, and are deep socket in which the talus first sungly, the tibia medial malleolus and the fibula's lateral malleolus create this mortise, allowing the ankle to move primarily in dorsiflexion, that means outward motion, and plantar flexion, that means downward motion. And the foot has 26 articulation, but the most important are going to be basically the tibia and fibula. And the articulation bones contain in three function units: the anterior or forefoot, middle and midfoot, and posterior, that is hindfoot. We have a picture over there in the screen of the division, the region of the foot: hindfoot, midfoot, and forefoot. We're going to start with the forefoot. This is the front section of the foot and plays a vital role in gait, balance, and propulsion. It includes the metatarsal and phalanges, which form a framework for the toes and are essential in supporting the body weight during the push-off phase of walking or the push-off phase of running. And the bony structure of the forefoot are the metatarsal, are 5 metatarsal bones, each corresponding to a toe. They are numbered from 1 to 5, starting medially with the first metatarsal, which is thinner or shorter, giving extra stability for bearing weight. And we had the phalanges. The two have 3 phalanges each, proximal, middle, and distals, except for the big toe, the hillux, which has only 2 proximal and distal. These bones give the toe flexibility and help with balance. The next region is the midfoot. Is the central part of the foot, linking the forefoot to the rear foot and playing a crucial role in shocking absorption. Another crucial role is stability and transfer of force through the foot. Its unique structure allowed it to support the arcs of the foot and adapt to various surfaces. We have the bony structure of the midfoot in the picture, and the midfoot consists of 5 tarsal bones that form the arc of the foot. We have the navicular bone that is located medially. It articulates with the talus and it's a key support for medial arc. We had the cuboid localized laterally. It connects the calcaneus and helps in stability of the lateral side of the foot. And we had three cuneiforms: the cuneiform medial, the cuneiform intermediate, and the cuneiform lateral, positioned between the navicular and the bases of the first three metatarsal. They play an important role in forming the transverse arc and supporting the medial longitudinal arc of the foot. We are going to go for the other region. The hindfoot plays a crucial role in ankle and foot mechanism by stabilizing the foot, supporting body weight, and providing stability and shock absorption. It's essential for smooth movements, balance, and proper load distribution. The bone structure of hindfoot are these two bones that we have in the screen, the talus and the calcaneus. And the talus or ankle bone is positioned between the tibia and the fibula, and the calcaneus, it forms the talocrural joint or ankle joint with the tibia and fibula, allowing for up and down movements. Basically, is dorsiflexion or plantar flexion. And we had other important bone in here is the calcaneus, and is also called as a heel bone. It is the largest tarsal bone and sit below the talus. It forms a foundation for the heel and provides leverage for the Achilles tendon, which attaches or is posterior surface. About the articulation, the key articulation of the ankle and foot basically are the talocrural joint and the subtalar joint. We're going to start with the talocrural joint or ankle joint. The primary ankle joint formed by the talus and the tibia or fibula is hinged. Is classified as a hinge that allows dorsiflexion, that means lifting the foot, or and plantar flexion, that means pointing the foot downward. In here we have the other important key articulation of the hindfoot, and is the subtalar joint or talocalcaneal joint is also called, is formed between the talus and the calcaneus, and this is crucial leading joint for inversion, inward rotation, and eversion, that means outward rotation of the foot. It allows the foot to adapt to uneven surface and assist in maintaining balance. Other important part of the ankle and foot for supporting are the ligaments, and we have in here that the hindfoot is reinforced by strong ligaments that stabilize this important anatomy part. Are approximately 100 ligaments in the ankle and foot region on lateral side of the ankle, but we're going to focus on the main ones. We're going to talk about the medial collateral ligament or deltoid ligament. This stabilizes the medial inner side of the ankle, connecting the tibia to the talus calcaneus and the navicular bones. We have another ligament. The lateral collateral ligaments include anterior tibular ligament, posterior talofibular ligament, and calcaneofibular ligament. this stabilizes the lateral side of the ankle. And well, we are going to talk about more about the ankle and the foot related to the arcs and connective tissues. We're going to start with the arcs, and the arcs of foot support by a complex network of connective tissues are fundamental for maintaining stability, absorbing shock, and allowing efficient movement. They help distribute body weight across the foot and adjust to various terrains. And there are three primary arcs in foot, each with a specific structural and function role. And we had the foot arcs, the medial longitudinal arc, as you can see on the picture. This is the most prominent arc running along the inside of the foot from the heel to the forefoot. It is formed by the calcaneus, formed by the talus, navicular bones, cuneiform bones, and the first three metatarsals. And the function, basically, it acts the main shock absorber and propulsion during gait. We have the other arc. This is the lateral longitudinal arc located on the outer side of the foot. This arc is less pronounced than the medial arc. It is formed by the calcaneus, cuboid, and the fourth and fifth metatarsal. And the function in this arc is going to provide stability, balance, and absorb lateral forces. And we have another important arc that is the transverse arc. This runs across the midfoot, spanning the bases of the metatarsal and cuneiform bones, and the function is to help distribute body weight evenly across the foot and maintains the structural integrity of the foot. Another important part of the ankle and foot are the connective tissues, and the connective tissues also support the arcs, and the arcs are supported by several types of connective tissues, including ligaments, tendons, and plantar fascia. And this structure work together to maintain the arc integrity and foot stability. We're going to talk in this part, as you can see on the screen, about the plantar fascia. The plantar fascia is a thick band of connective tissue that runs along the bottom of the foot from the calcaneus to the metatarsal heads. It plays a crucial role in maintaining the medial longitudinal arc by supporting the arc when the foot bears weighting. And the plantar fascia stretches and stores elastic energy during foot strike, helping propel the foot forward during gait. Well, this was ankle and subtalar Boney structure and articulation.